Okay, now we're going to talk about conjectures and conditional statements. Now, a conjecture, as we've already said, is just an educated guess. Conjectures can be either true or false. Sometimes it's very easy to tell if a conjecture is true or false. Other times, it's not so easy. Let's take a look at example number 1. We have a given statement that says points P, Q, and R are collinear. And you make a conjecture that point Q is between points P and R. And we'd like to determine, is this conjecture true or false? Well, I could draw a picture that shows that this conjecture is true. Let's see, if I have point P here, and if I have point R here, and if I put point Q, let's say I put point Q right here, well, that shows 3 collinear points, and Q is between P and R. So I might be tempted to say this conjecture is true. However, if I can come up with just one example that shows this conjecture to be false, then I've proven the conjecture false. And it's not that hard to draw a picture that has points P, Q, and R collinear, and yet has point Q, let's say point Q right here, point P right here, and point R right here. Now I have 3 collinear points, P, Q, and R, and yet Q is not between P and R. This is what's called a counter example. And a counter example is just an example that shows a conjecture to be false. So this conjecture is false since I've come up with a counter example. I've come up with a picture that shows 3 collinear points, P, Q, and R, and yet Q is not between P and R. All right, now let's talk about conditional statements. A conditional statement is just a statement that is written in the form if A, then B. The part of the statement following if is called the hypothesis, and the part of the statement following then is called the conclusion. So if I have a statement in the form if A, then B, this is the part of the statement following the word if, that's called the hypothesis. This is the part of the statement following the word then, that's called the conclusion. Now, if I just have it written like this with the letters A and B, well, it's kind of easy to identify. This is the hypothesis, this is the conclusion. When you have actual English statements of conjectures or of conditionals, then it's sometimes a little more difficult to identify the hypothesis and conclusion. So let's take a look at some examples where first we're given a statement that's not in conditional form. We first want to put it in conditional form, and then we want to identify the hypothesis and conclusion. So example 2, our given statement is perpendicular lines form right angles. And if we take this statement and put it in conditional form, which means if then form, then we would say if 2 lines are perpendicular, then they form right angles. So it's in if then form. Now we can identify the hypothesis, which is the part of the statement that follows the word if. So this is the hypothesis. And the conclusion, which is the part of the statement that follows then. Notice the word if and the word then, they're not part of either the hypothesis or the conclusion. They just help us to identify where are the hypothesis and the conclusion. All right, so the hypothesis does not include the word if, the conclusion does not include the word then. Let's take a look at example 3. Our given statement is a figure with 3 sides is a triangle. So we want to write this statement in conditional form, which means if then form. So we write if a figure has 3 sides, then it is a triangle. Now that we have it in if then form, we can identify the hypothesis, the part that follows the word if, and the conclusion, the part that follows the word then. Now we're going to talk about something called the converse, the inverse, and the contrapositive. If we have a given conditional statement which, as we've mentioned, is in the form if A, then B, then we can take that statement and we can make, from that given conditional statement, we can make three other types of statements. First type of statement we can make is called the converse. And if our conditional statement reads if A, then B, then the converse would read if B, then A. We just swap the hypothesis and conclusion. The inverse would read if not A, then not B. In other words, we take what we call the negation of the hypothesis and the negation of the conclusion and write if not A, then not B. The contrapositive is a form of a statement that reads if not B, then not A. So you see we take the negation of A and B and just swap them. Let's take a look at some examples of this using actual statements. Example number 4. People who live in Siler City live in North Carolina. That's our given statement. We want to first create from that a conditional statement, so we want it in if-then form. If someone lives in Siler City, then they live in North Carolina. Now from this we want to create our converse. Well, remember, to create the converse we just swap our hypothesis and conclusion, so the converse would read if someone lives in North Carolina, then they live in Siler City. We've just taken our hypothesis and our conclusion and swapped them. If we want to write the inverse, we want to first take the negation of our original hypothesis. Well, our original hypothesis, which is someone lives in Siler City, we want to say if someone does not live in Siler City. That would be the negation of the hypothesis, the opposite of the hypothesis. Then we want to have the negation of our original conclusion. So we have if someone does not live in Siler City, then they do not live in North Carolina. That's our inverse. To write the contrapositive, we take the negation of our original hypothesis, the negation of our original conclusion, and swap them. So that gives us if someone does not live in North Carolina, then they don't live in Siler City. Now, once we've written each one of our 4 statements, the conditional, converse, inverse, contrapositive, we often want to determine what's the truth value of each one of these statements. That is each statement true or false? Well, let's look at each one of these statements and decide if they're true or false. If someone lives in Siler City, then they live in North Carolina. That is a true statement. Siler City is a city that is in North Carolina, so if someone lives in Siler City, they must live in the state of North Carolina. The converse says if someone lives in North Carolina, then they live in Siler City. Well, that's obviously a false statement because I live in North Carolina and yet I don't live in Siler City, so I could use myself as a counterexample. So the converse is false. How about the inverse? If someone does not live in Siler City, then they don't live in North Carolina. Well, once again, I don't live in Siler City, and yet I do live in North Carolina. So this statement here is false because, again, I can use myself as a counterexample and show that this is false. The contrapositive, if someone does not live in North Carolina, then they don't live in Siler City. Well, let's see. If someone doesn't live in North Carolina, like, for example, if they live in California, then, yeah, they can't live in Siler City. So this would be a true statement. Let's take a look at example number 5. We have a given statement that says squares have 4 sides. First thing we want to do is we want to write this statement in conditional form, that is if-then form. So if a figure is a square, then it has 4 sides. This is my hypothesis, and this is my conclusion. Now from this conditional statement, I can create my converse, inverse, and contrapositive. First I create my converse. I just swap my hypothesis and conclusion and write if a figure has 4 sides, then it is a square. To write the inverse, I need to take the negation or the opposite of my hypothesis and conclusion. So if a figure is not a square, then it does not have 4 sides. Finally, to write the contrapositive, I take the negation of my original hypothesis and conclusion and swap them. So if a figure does not have four sides, then it is not a square. So now again, I have my four statements, my conditional, converse, inverse, and contrapositive. I want to determine the truth value of each one of these statements. Are they true or are they false? So let's start with the conditional. If a figure is a square, then it has four sides. That's true. All squares must have four sides. The converse says, if a figure has four sides, then it is a square. Well, let's see, can I think of a counterexample that would prove that statement false? And yes, I can. If a figure has four sides and it's a square, I can think of, for example, a rectangle. That's a figure that has four sides, and yet it's not a square. So the converse is false. How about the inverse? If a figure is not a square, then it does not have four sides. Well, again, I can think of a rectangle, and that's not a square, and yet a rectangle does have four sides. So that makes the inverse false. Finally, the contrapositive. If a figure does not have four sides, then it is not a square. So let's see, figure that does not have four sides, that would be, say, a triangle. That's not a square. Pentagons don't have four sides. Yeah, that's got to be true. If a figure does not have four sides, it can't be a square. Now, you have one more example in your notes, and I want you to try that one on your own, and also determine the truth value of each one of the four statements that you come up with. And then I want you to see if you can determine if there's kind of a pattern that we start to notice in the truth values of each one of the statements that we create. And we'll talk about that some more tomorrow in class.